So at this point, we need to ask ourselves, what should we attribute to the individual, and what is better understood if we consider the relations between individuals? That has been a theme throughout this section on social cognition. If we attribute everything to the individual, we end up ignorant about the social forces that animate us, that link us, that drive our lives as much as anything internal. The problematic studies we looked at in social psychology arise in specific contexts in which specific social fears are at play. So it's hard to know how to come at our collective behavior, how to understand those patterns that we collectively give rise to. And we have a tradition of attributing too much to the individual, assuming that the individual is responsible for every aspect of their lives. So we're going to finish up with just a glimpse at an alternative way that science can approach such questions, starting with the observation of some well-defined collective phenomenon, and then asking, well, given this collective phenomenon, what should we attribute to the individual and what should we attribute to the relationships between the individual? So we're here holding off from deciding what a person is or what should be attributed to an individual brain, motivation, or mind. Forget that talk. We're going to try something different. We're going to start with the collective phenomenon and work backwards to an appropriate characterization of the individual and the relations between individuals for that specific phenomenon. So we're being a bit cautious here. Here's an example of a collective phenomenon that has been studied, modeled, and can inform us here. This is the so-called Mexican wave that occurs in a crowded stadium. You've all seen the Mexican wave on telly. You get a bunch of people into a stadium, and if they feel like it, and if the situation's right, and someone starts, you get this phenomenon. The phenomenon is the traveling wave. We're not asking about people here, we're asking about that traveling wave. And that's a well-defined phenomenon, and when you have a well-defined phenomenon, you can ask, what does the individual contribute to it? And what should we attribute instead to the relations between individuals? So there are scientific questions you might ask about this phenomenon, about this collective wave. You might ask, how many people do you need to start it? How close together do they need to be? How fast will it travel? Which direction will it travel? What are the conditions under which it propagates, and what are the conditions under which it's extinguished? What is the simplest characterization of both the individual and their relations that can allow us to account for this? And with those questions in mind, you can develop a model. This is a computational model, and it comes from the stall of Tomasz Wiesiek, the third author there, who has a wonderful body of work studying shoaling phenomena, flocking phenomena, the movement of large herds of beasts, traffic jams, pedestrian behavior. All these are collective phenomena. And I'll just show you what this model looks like when it's working. There you can see what we're doing is reproducing the movement of a Mexican wave in a computational model. And we're not going to dig deep into this model, but what I want to show you is the intellectual problem that is solved here. We start with the collective phenomenon, the wave, and then we ask what's the simplest joint characterization of an individual and the relations between individuals. And this computational model was developed on the basis of a very similar model, which sought to capture the manner in which electrical signals are propagated in heart tissue. So if you have a petri dish with heart tissue and you stimulate one cell, that stimulation propagates through the tissue. This has been very, very well studied, and in the context of the heart tissue, you don't try to invest each cell with dreams, hopes, ambitions, memories, and such. No, you model each cell in the simplest possible way in order to capture the collective phenomenon. The role of the individual is small and the individuals are simple, and if we get just the right kind of interactions, then we can reproduce the collective phenomenon. In the case of the Mexican wave, what each individual is modeled just as a simple oscillator that fires or not, based on what those few people who are spatially around the individual are doing. Here's an example of the same kind of intellectual mindset brought to bear on the mosh pit. If you're not familiar with the mosh pit, go check it out on YouTube. Mosh pits are violent agitations of humans, but they display specific kinds of regularities, and even under specific circumstances, they display very, very interesting collective phenomena. A large agitated mosh pit can suddenly transform into a circular pattern and back again. So there's an example of a computational simulation of a mosh pit. The same logic is followed. That is, you jointly arrive at a characterization of the individual and the interactions among them. And your characterization of the individual is appropriate for this phenomenon. It is not a model of a person, although a person plays that role when they're in the stadium. You also, of course, have to carefully pay attention to the circumstances in which those interactions take place. This kind of collective dynamical modeling comes from physics, but it's proving very, very useful for understanding phenomena that we usually assume derive from the individual. So I suspect that most of what goes on in the domain of economics, in politics, and in psychology can learn an awful lot from this. So good social psychology will be alert to both intra and inter-individual contributions to a phenomenon that is observed. And notice the scientific demand that we start with a well-defined phenomenon. We don't start in the abstract. We start with something that is real that needs to be characterized. Using the approach from collective dynamics, what we would do is, for a particular phenomenon, arrive at a particular solution. We need to be flexible then with respect to the role that's given to each individual. I think there are important lessons there.